Let's try these examples. For part A, we have 1 over 27 equals 3 to the 2x. Okay, so let's use this property. Okay, if b to the x equals b to the y, that is, if you can get the same base, then x equals y. Then we can just set the exponents equal to each other. Okay, so we need the same base here. I'm thinking that 3 is as simple as this base is going to get. So let's see if we can write 1/27th as something with base 3. I'm going to go over here and do this on the side. So 1 over 27, well, I know 27 is 3 cubed. Okay. This is still in the denominator, but note that we can write this as 3 to the negative 3. Right? These are the same thing. 1 over 3 to the 3 is the same thing as 3 to the negative 3. And that does the trick right there, 3 to the negative 3. So going back to our problem, I'm rewriting 1 over 27 as 3 to the negative 3 on the left, and then on the right, we're just going to keep the 3 to the 2x. And that's exactly what we wanted to have happen, because now our bases are equal, so we can just focus on the exponents and set those equal to each other. Okay, so this gives us negative 3 equals 2x. Divide both sides by 2. That gives us x equals negative 3 halves. There we go. First one is solved. For part B, we have 4 to the 3x minus 7 equals 32 to the 2x. Okay, we want to use this property again. We want to get both of these with the same base. Well, maybe we could try for 4. Nah, because 34 is not a power of 4. If we just looked at the powers of 4, we'd have 4, 16, and then 16 times 4 would be 64. So it skips 32. So we can't write both of these base 4. Maybe we can use base 2. How about that? Because 4, let's go down here, as a little side note, 4 is 2 squared, and 32 is 2 to the what? Let's see, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. Okay, and that will get us where we want to be. Right, so let's rewrite this as, instead of 4, we have 2 squared to the 3x minus 7 equals, and instead of 32, we have 2 to the 5th, all raised to the 2x. Okay, well, when you have a power raised to another power, those powers multiply together. So this is going to become 2 to the power of 2 times the entire quantity, 3x minus 7. So I would recommend putting parentheses or whatever it takes to remember that this 2 goes through to everything, not just the 3x. That's the left side. On the right side, we multiply exponents again. We get 2 to the 5 times 2x, 10x. So we're certainly getting closer. Actually, right there we could do it, right? Because now we have the bases are the same, 2 and 2, so we can just peel off these exponents and set those equal and forget all about the bases. Okay, so let's do that. So just focusing on the exponents, we have 2 times 3x minus 7 equals 10x. Now we just want to solve this for x. So let's go ahead and distribute this 2 through and see what happens. 6x minus 14 equals 10x. I'm going to subtract 6x from both sides. Negative 14 equals 4x. Dividing both sides by 4 then gives us x equals, well, we can simplify 14 fourths, right? Cancel a 2 out of both of those. That leaves us with 7 halves. So x is negative 7 halves. There's our answer for part B.